In this lesson today, we're going to be learning about moles, which we learned about just the other day, and we're going to be relating them to what we refer to as molecular masses, which may be a new term for you. It's something we're going to learn about today. So our objectives for today are we will be able to calculate the molar mass of a substance from its chemical formula, and we're also going to be able to, again, we're going to do some more conversions between the moles, which we've already done, and the number of particles in the substance, but now we're going to throw in something new. We're going to throw in the mass of the substance as well. So just as a quick review from what we learned the other day, we learned about Avogadro's number. We learned that number is equal to 6.02 times 10 to the 23rd, and we learned that 1 mole, just like 1 dozen, is equal to that number right there. And that using that conversion, that 1 mole equals 6.02 times 10 to the 23rd, whatever, we can convert between the moles of a substance and the number of particles of that substance. Okay, one thing that we haven't talked about yet, though, is that obviously a lot of these substances have different particles, therefore they have different masses. And the masses are what we're going to start focusing on today. We're going to look at how we can relate the moles of the substance to the mass of the substance. So one thing again we already know is that 1 mole is equal to 6.02 times 10 to the 23rd. That's our definition of a mole. And so far when we've been talking about the whatevers, we've basically been talking about atoms and molecules, things like that. But remember, it can be whatever we want it to be. I think the example I used the other day, we talked about if you had a mole of dimes, how it would cover the earth 10 miles deep. Or if you had a mole of paper, it would go all the way to the moon and halfway back. Those whatevers we can use obviously have masses as well. And so we're going to use moles to relate to the mass of those atoms or molecules or whatever we happen to have. So in order to do that is we have to start using the periodic table. As we know from the periodic table that when we're given an element on the periodic table, you've got your carbon in the middle, you've got the 6 on top, and then you've got the 12.011 on the bottom. This number on the top we call the atomic number. That's our number of protons and our number of electrons in a neutral atom. And then this number on the bottom here is what we would call the atomic mass. And so now we're going to start using that number here on the bottom again, using obviously the periodic table. So in a molecule such as glucose with C6H12O6, we have 6 carbon atoms, so that 6 refers to the number of carbons. The 12 is the number of hydrogens, and the 6 here is the number of oxygens. So we've got 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. And so when we're determining the mass of that whole molecule, we can go to the periodic table and we can just look and see what the mass of each atom is. So the mass of carbon is 12.0, and then we just times it by the number of molecules, or the number of that atom that we have. So we're going to go 12.0 times 6, that's our carbon part. Hydrogen has a mass of 1. We times that by 12 because there's 12 carbons. And oxygen has a mass of 16, and there's 6 of them, so we multiply it by 6. And so what we can say is that the mass of glucose is 180 grams. But again, the question is, how much do you actually have if you have 180 grams? And that's where we get to this concept called the molar mass. The molar mass is the mass of 1 mole of that substance, and it's equal to the weight or the mass of the periodic table that you find on the periodic table. And so in this case, when we say 180 grams, that means that glucose, if you had 1 mole of glucose, we know that that is equal to 6.02 times 10 to the 23rd, again, molecules. But what we also know now is that 1 mole of that substance. So if we had exactly that many molecules of glucose, it would weigh 180 grams. So a mole is useful for not only getting our number of atoms, molecules, whatever, a mole is also useful for converting between the moles of the substance and the mass of the substance. When you're doing an experiment with this, when you're weighing things, you're getting the grams of something. But a lot of times the calculations that we do don't involve grams, they involve moles. And so this is going to be our way to convert from the grams of something to the moles of something. So it kind of is basically going to look like something like this, where we know that to go from moles to particles, we use, I'm just going to put AN, Avogadro's number, but now we're learning that to go between grams and moles, we're going to be using the MM, which is the molar mass of that substance. So the way that you calculate the molar mass is, again, you find the mass of each individual atom and you multiply it. As you can see on all these, we multiplied it, and then you add them all together. Okay, so we can say that the molar mass of glucose, as we just talked about, is 180 grams per mole, and that means 180 grams in 1 mole. And we'll do some calculations with this here in just a little bit. So let's make sure we know how to do this. When we're calculating molar masses, we need to be able to determine the total mass of each molecule. So for example, on barium sulfate, the way we would determine the mass of that, you find the mass of barium, and there's only one of them. You find the mass of sulfur, again, only one of them, and then the mass of oxygen, and you times that one by 4, and you get your mass. Okay, for the second one, water, you've got 2 hydrogens, so find the mass of 2 hydrogens, add it to the mass of 1 oxygen, and you'll have your molar mass. So for all of these, take a few minutes at this point and pause the video and figure out the mass of each of them. Once you have the mass of each of them, then go ahead and continue the video and we'll look at our possible answers. So pause the video now, please. All right, welcome back. Let's go ahead and take a look at our answers here. These are the answers that I came up with for each of them. So for number 1, for barium sulfate, I got 233.4 grams per mole. Water, 18, and you can go through the rest of them there yourself. If there is a problem or if possibly I made a mistake, go ahead and talk to me about it, and we'll figure out what went wrong. The only thing I want to make sure that we're clear on is this, on this calcium nitrate one, make sure that that 2 goes to the nitrogen and the 2 also goes to the oxygen. So when you did that one, you should have had 2 times the mass of nitrogen, and then 2 O3s means there's 6 oxygens. So it's 6 times the mass of oxygen. So same thing here with the ammonium. NH4, there's 3 nitrogens, but then there are actually 12 hydrogens. So if you made a mistake, that's possibly where it may have happened. So on this last one, 3 carbons and 9 oxygens. 3 times 3, 9 oxygen atoms. Now, how do we do these conversions? So just like before, when we converted between the molar masses when we converted between the moles and the particles, we used the 6.02 times 10 to the 23rd. So now we're going to be using the molar mass, and we're going to be using the grams to get the different masses of our compounds. So calculate the number of moles of glucose in 5.380 grams of glucose. So our first thing that we're going to set up is we're starting with grams, and we need to get to moles. So when you convert grams to moles, you're using the molar mass of glucose, which we've already found earlier. So our first thing that we're going to do is, notice here we've got our 5.380 grams of glucose. You always start with the information that they give you. And then we want to cancel our grams. And so in order to cancel our grams, we're going to put grams on the bottom. And so when we do our conversion, when we use that molar mass of glucose, from the periodic table, remember we said it's 180 grams per mole. So in this case, since we want to cancel grams, the grams part has to go on the bottom, and the mole part, therefore, will go on the top. So there we can see our grams are canceling out. All we have left are moles. And then when we do our calculation, we're going to take 5.380 and we're going to divide it by 180. And remember, the 1 we don't need to do anything with. So 5.380 divided by 180. And then our final answer, we've got 4 significant digits here. So my final answer, I get 0.02989 moles of glucose. Now, as we know, well, here, we'll do this one here first. So in this case, it says calculate the mass in grams of 0.433 moles of strontium phosphate. So in this case, we're going backwards. So we've got 0.433 moles of SR3PO4 and now we want to cancel moles. So notice how we set up this one. In that one, we wanted to cancel grams, so we put grams on the bottom. In this case, we want to cancel moles. So first of all, we need to figure out the mass of SR3PO4. So we've got 3 strontiums. Strontium has a mass of 87.62. So when we do this, we really just need to go out 1 decimal place past the decimal point. So we're going to go 87.6. And because there's 3 strontiums, we're going to times that by 3. So that gives me 262.8. And then phosphorus, again, it's in parentheses. There's 2 of them, though. So we're going to take the mass of phosphorus, which is 30.97. We're going to round that up to 31. So 31 times 2 is 62. So we're going to add that to our 262.8. So now I'm at 324.8. And now we've got 4 oxygens, but again, now there's 2 of them. So that's 8 oxygens. Oxygen is, we're going to, again, rounding that, we get 16.0. So 16 times 8 is 128. We add that to our 324, and my total mass, so the molar mass of strontium phosphate is 452.8 grams per mole. So again, that means if I had exactly 6.02 times 10 to the 23rd particles of strontium phosphate, then the mass of it would be 452.8 grams. So what we can do is, again, we want to cancel moles. So here's my conversion right here that I'm using. I'm using my mass from the periodic table. And we can say 1 mole, because that's what we want to cancel. And then on the top, we're going to put our mass, 452.8 grams. So now this becomes a math problem. 452.8 times 0.433 equals 3 significant digits, 196 grams of strontium phosphate. All right, so besides just interconverting between grams and moles, so far what we've learned is we've learned this one right here. If you have grams and you need to go to moles, how did we do that? Let's come back to here real quickly. We had grams and we got moles. How did we do that? We divided by the molar mass of the substance. So to go from grams to moles, you divide by the molar mass, molar mass. Now if we went the other way, which is what we did in our second example, to go from moles back to grams, let's go back here. We went here from moles back to grams. What did we do with our molar mass? We multiplied by the molar mass. So to go this way from moles to grams, we times by, again, I wouldn't write if I were you. I would write molar mass. You can write smaller than I can here. So now, and again, what we've already learned is that you can go from moles to particles. And I kind of started to write this earlier. And again, those particles can be atoms or molecules or whatever. And we know that to do that, we use 6.02 times 10 to the 23rd. So to do that, you can go back and forth. And in this case, I'm just going to write AN, Avogadro's number. That's 6.02 times 10 to the 23rd. So theoretically, we could start with grams and go all the way to particles. So here in this case, they want to know how many molecules are there in 5.23 grams of glucose. So let's look at what I did here. So we're going to start with our grams. So we have our 5.23 grams of glucose. So notice my first step right here is what we've already done. We've converted grams to moles. The way that we do that is we cancel our grams. We have grams on the bottom. We have our 1 mole on the top. And now we've converted to moles. Now instead of stopping right there though, now we're just going to go to our next step where we're going to go from moles to particles. In this case, it's not an atom, it's a molecule, and that's fine. It doesn't matter. Remember, the 6.02 can be whatever we want it to be. So in this case, we want to cancel moles. So what happens is we put moles on the bottom over here, and there we can see that red line going through there and canceling out our moles. Now a mole is equal to 6.02 times 10 to the 23rd, in this case, molecules. So when we do our math, we're going to take our first number, 5.23, we're going to divide by 180, and then we're going to multiply by 6.02 times 10 to the 23rd. And when you do that, if you've done it correctly, that's the answer that you should come up with, 1.75 times 10 to the 22nd molecules. So you'll notice when you have moles, there's two different things you can do. You can go to grams, or you can go to particles. If you start with one or the other, if you start with grams or you start with particles, you can go all the way from one side of the equation to the other, again, using your moles. So one of the things that we could also do, now that we've got to this point, is we can also calculate atoms. So we know that in this molecule, this is something we talked about at the beginning, and in this molecule there are 6 carbon atoms, there's 12 hydrogen atoms, and 6 oxygen atoms. And so if we come back here to this answer, so again, we're starting with our 5.23 grams of glucose, and we're going to go from that all the way to how many oxygen atoms there are. So since we know how many molecules there are, we can also say that in one molecule, that's a U, one molecule, there are 6 oxygen atoms. And so again, that's another conversion we can use. So our last step we could do is once we have molecules, is we could convert molecules to atoms using this conversion right up here. And that would be our final answer for atoms of oxygen. Now, let me kind of show you what that whole thing might look like. So if you've got grams, so let's say we're going from grams of CH4 all the way to atoms of hydrogen. Okay, so if the question is asking you, you have 25 grams of CH4, how many actual atoms of hydrogen do you have? So the first thing is you start with the grams that they give you. You go from grams to moles using the molar mass of CH4. And then you would go from moles of CH4 to molecules of CH4. And again, you would use AN, Avogadro's number. And then your last step, the one I just showed you, is you could go from molecules to atoms of hydrogen. And in that one, what do you use to go from molecules to atoms? Is you use the actual CF, the chemical formula. And you go, in this one molecule of CH4, there are 4 carbons. Or excuse me, not 4 carbons, 4 hydrogens. And so you would use that to do your very last step. Okay, so hopefully that last one I just put up on the screen, hopefully you wrote that down. If not, back the video up and write that down. Okay, so our objectives we're to be able to calculate the molar mass of a substance. So looking at the periodic table, can you determine the molar mass of any substance? If you can, great. And then can you now convert between the moles of something, the mass of something, and the number of particles? If you can, then you are in good shape. Here's one last question for you that we can do here together. And this is a good test. If you can do this problem, then you are in good shape in terms of, do you understand the big concept of today? So this one, they're giving us 13.4 grams of aluminum sulfate, and we have to calculate how many oxygen atoms are in that sample of aluminum sulfate. So I'm gonna go back here a little bit. We've got 13.4 grams of aluminum sulfate. So let's give us a blank screen here. And we've got 13.4 grams. Now, they told us 13.4 grams of aluminum sulfate. So the first thing you have to be able to do is remember the formula for aluminum sulfate. So aluminum is a metal. It has a +3 charge. Sulfate is a polyatomic ion. It's SO4 2-. So therefore, the formula for aluminum sulfate is going to be Al2SO4 3. Or remember that our charges trade places there. All right. So that's our grams. When you're given the grams of something, really the only thing you can do with those grams is convert those grams to moles. So that's our first step, is we're going to get moles. So we've got grams on top, and we want to cancel them. So we have to figure out the molar mass of Al2SO4 3, which I get as 342.3. So I'm going to go 342.3 grams on the bottom. And the reason, again, I put that on the bottom is because I have grams on top. I want grams to cancel. And that's the number of grams in 1 mole of Al2SO4 3. Now I'm going to continue. I'm going to jump down here just because I'm out of room. Now I want moles to cancel. Moles are on top, so I'm going to put 1 mole on the bottom. Moles are going to cancel. And I'm going to get 6.02 times 10 to the 23rd. And that's going to be molecules of Al2SO4 3. And now that I have molecules, now I can do my last step where I'm going to go from molecules to atoms. So the question was, how many oxygen atoms are there? Well, in this 1 molecule, we know that there's 4 oxygens here inside the parentheses, and then the 3 outside, we got to times it. So there are 12 oxygen atoms. So in 1 molecule, there are 12 oxygen atoms. So now to solve this problem, we take 13.4. So we're just starting with the first number that they give us. If a number's on the bottom, we're going to divide it. So divided by 342.3. And then we're going to times that, because this number is on the top, times it by 6.02, exponent to the 23rd power, and then we'll multiply it by 12, which gives me a total of 2.83 times 10 to the 23rd, and that's the number of oxygen atoms in, again, that sample of aluminum sulfate. So notice we're going from grams to moles, moles in this case to molecules, molecules to atoms. And that is our introduction to molar masses.